What's up, kids? This is Mr. Carlson, C-squared mathematics, and now we are on day 2 of graphing quadratic equations. We're going to look at the intercepts and then the standard form. If something like the graph, the quadratic graph, is in standard form, if that's in standard form, how can I graph it? How can I use the intercepts to graph it? And how do I find my vertex? So we are going to be talking about that today. Let's go through the bell work, then get you started on the homework quiz if you want to, if that helps raise your grade. And then we're going to ask the essential question and then get to the lesson. These are the only 2 questions that I have for us during the bell work. So I'm asking find the x-intercepts and then find the domain and range and then briefly graph the quadratic equation. So basically, where would this quadratic equation lie? What would it look like? I probably may or may not graph this. I'll probably graph both. Yeah, I'll just graph both. But yeah, let's do that. Let's do the x-intercepts, domain and range, and then we'll briefly graph it. So for the first one, x-intercepts, then domain, and then graph the quadratic equation. Let's put the graph here. For the first one, how do I find the x-intercepts? Well, there's a couple things you could do here. First of all, I need to set it equal to 0. You could FOIL all that out, but why would you want to do that when you can just do the square root property? So I'm going to keep it like that, add the 2 over. This is 4, and then x minus 2 squared. Divide by 4, so now it's going to be 2 all over 4 equals, and then this is x minus 2 squared. Now I'm going to square root and then square root. So when this happens, what I get is the square root of 2 all over 2. Okay? I get the square root of 2 all over 2. That's what I have. Okay? I get the square root of 2 all over 2. So this equals, and then that goes poofy. This is x minus 2. So far, so good? Okay. I add the 2 over. Awesome. So I'm going to kind of flip it as well. So I'm going to actually do this, x equals. I'm going to add the 2 over, so this is 2. Now remember, since I did the square root here, technically it's plus or minus. So this is plus or minus the square root of 2 all over 2. Now I do need to combine fractions here. So this is all over 1, but times 2 gives me 2, times 2 gives me 4. So my actual answer is 4 plus or minus radical 2 all over 2. This is my final answer. Now maybe you're thinking, well, can't you divide by 2 by everything? Wrong. No. You can only do that if this number right here, right before the radical, if that number is 2 or 4 or 6, basically an even number. But guess what that number is, guys? That's a 1, which is odd, which means you cannot divide everything by 2. If you're thinking, oh, can I divide this radical 2 by 2? No, the radical 2 is basically its own entity. It's like pi. Okay, remember pi from geometry? Pi is 3.14, blah, 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 right? You wouldn't be able to do that. I mean, it's basically, think of a radical almost like that. It's just a decimal, but it's its own decimal that you can't just divide into it. You can't do that at all. So no, you can't simplify that question any further, and that's what it's going to be. So let's get to our domain and range. What's my domain here? My domain is, of course, negative infinity to positive infinity, because that's my domain for all quadratics. My range is a little bit interesting here. I need to find my vertex in order to even find my range. So what's the vertex? Let's do like a side note here and just say like a star. This is my vertex. So my vertex is of just 2, negative 2. So it probably will ask you for the vertex. Maybe when you're graphing it, you do need that vertex eventually. So that's nice. Yeah, that's fantastic. But it probably won't actually ask you say the vertex. It'll probably just be in the graph. That's what I'm trying to say. So what's my range? Well, look at my y value. It starts at negative 2. This is a positive. So if that's a positive, that means it looks like this. It goes up, right? So if it goes up, then that means what we can say is, all right, it starts at -2, and then it goes up to infinity. And that's going to be my range. If I wanted it in set notation, it's the set of y, all y such that y is greater than or equal to -2. Okay? Awesome. And of course, briefly graph it. So if I wanted to graph this thing, it would look something like this. So my vertex is 2, -2. So 2 and then -2, and then it goes up. So it just looks something like this. Very briefly, I'm just kind of sketching it, and that's about it. I don't even know if it goes across the y-axis or not. I don't care. I just know it's going to look something like that. Okay. Oh, FYI, if you're still struggling on like the plus and the minus with the vertex and if it's going to open up or down, just think about this. If it's plus, it opens up. Okay. If it's minus, it goes down. So those are nice, I think, to just kind of help us kind of remember. I didn't show you that in the last video, but I'm showing it to you now. All right, right here, let's actually start with the vertex right away because that's probably beneficial, right? So -5, 2, that's my vertex. Let's actually solve for the x-intercepts as well. So I'm going to set this equal to 0. This is my first step here. Set that equal to 0, and then I'm going to start solving. So square and then +2. So I'm going to add the 2 or subtract the 2 over rather. So subtract the 2 over. This is -3, and then x plus 5 squared. Divide by -3. So this is 2 all over 3 equals, and this is x plus 5 and then squared. I still want to square root this. I still want to square root this, but this does look like a nasty radical here. Okay. So I'm actually going to flip the whole thing too. So it's going to be x plus 5 equals plus or minus, and this is radical 2 all over radical 3. Now the problem with this is I need to rationalize it. I can't have the radical on the bottom. Here, the radical was not in the bottom because radical 4 down here is just 2. And so I didn't really need to do anything with that. Here, I do need to rationalize it. So let's rationalize this baby. This is radical 3 and then radical 3 on the top. So this is how you rationalize. Just remember, that's how I do it. So this is plus or minus. Radical 2 times radical 3 is radical 6. And then in the bottom, radical 3 times radical 3 is just 3. Okay? And then, of course, I still have x plus 5. So what do I do now after I move my little face? I'm going to finish it. Let's finish it up here. So I'm going to subtract the 5 over. So x equals -5 plus or minus radical 6 all over 3. I do need to combine like terms here, which means I need common denominators. This is all over 1. So times 3 gives me 3. Times 3 gives me -15. So -5 times 3 gives me -15. So my final answer is -15, and then plus or minus radical 6, and then all over 3. Again, I cannot simplify this any further. It's not like I can divide everything by 3 here. Oh, 15, 6, and 3 can be divisible by 3. So therefore, no, I cannot say that. 6, radical 6 is its own variable term. So you cannot touch the radical 6. The only way you can touch the radical 6 is if you can break it down more. You can't. The factors of radical 6 is just radical 2 and radical 3, which is how we got radical 6. 2 times 3 is 6. But those are prime, so I can't break it down anymore, which means that's my final answer. Briefly, let's graph this because, or actually, let's do the domain and range first. Domain and range. My domain, of course, is always going to be -infinity to +infinity. Okay. My range. Notice how this is a negative, so that means it has a max. So that means looking at this, it's still going to be 2. I'm still going to be at 2 eventually, but I'm going to actually start now with -infinity. The reason why I'm going to start with -infinity is because that graph is pointing down because it's a negative. So when I read range bottoms up, I reach the graph first in the negative infinity. Here, I didn't reach the graph down in negative infinity. Like this is down in negative infinity, and I had to go up to finally hit this point, right? That's not the case here. I start with negative infinity, and then I stop at 2, my y value. And of course, this is going to be in brackets. So what is this graph going to look like briefly right here? Yeah, so -5, 2. So -5 is right here, and 2 is going to be somewhere right here. So let's just plot that point. This is my vertex. And then, like I said, it goes down. So it looks something like this. Now, again, this is a brief sketch. I don't even know if it's completely accurate, probably not, but it is something like that. I know the vertex is in quadrant 2, and I know it points down as such, okay? Awesome. Those are the 2 questions I only wanted to go through the bell work. Let's erase. Make sure you pause the video so you can get it. Let's erase, get you on the homework quiz, and go to town. So I hope now you're kind of seeing how to relate quadratic equations with its graph, its equation, its x-intercepts, its domain and range. I hope all of that's kind of compiling together finally for you so you can get a firm grasp on what quadratics are, what parabolas are, and how they relate to the x-intercepts and so forth. That would be wonderful if you can get that. Homework quiz, 5 questions, 25 minutes. Open notes. If you have any partial credit requests, just let me know. Just email them to me. Okay? And then graph quadratic equations, part 2. We're going to do that right now. So, how do I graph quadratic equations? And then solve systems of equations, including quadratics. Now, this is actually something that we did before called nonlinear systems. We're going to review at least one question, probably just one question there, because you'll see it on the homework. And they're really beneficial just to see how you can graph a quadratic equation, but also how it intersects other linear equations. Okay, we are going to do a little bit about translations and shrinking and stretching, of course, but primarily we're going to be looking at just the intercepts and standard form. But we're going to be using all the same stuff that we did yesterday. So here's the first slide, vertex form. We do know what vertex form is. That's what we learned yesterday. But CTS, what is that? Remember from last week, CTS stood for completing the square. So when I say CTS, I mean completing the square. And what if we are given to something, a quadratic function, a quadratic equation, that's not in vertex form, but rather it's in standard or what we call general form? What do we do then? And we can't just pull out the vertex just as easily as we could with vertex form, right? Well, what we can do is we can put the standard form equation as such into vertex form by completing the square. So here are the steps for completing the square. These are steps that you already have in your notes from last week, so you don't necessarily need to write them down again, but by all means, if you want to write them down, you can write them down. So let's get started. What do we do here? If I'm given a function that's in standard form, how can I find the vertex here? How can I find what the vertex is? Well, one thing I can do is simply just put it in vertex form. That way I can pull out the vertex and I can graph it just as easily, just like what I did yesterday. So we're going to do that. This is in standard form. My first step says factor out the LC, which is the leading coefficient. If A is not equal to 1, so A is your A value, that value before your X here, well, clearly A is 1, so that means this step does not apply. I'm not going to factor out a 1, because when I factor out a 1, I just get everything else. So let's go to step 2. Take half and square the B term. So take half of and then square the B term. So let's look at that, okay? I want to take half of this and square it. But as I'm doing this, notice what we have is not necessarily in completing the square form. So I am going to do this, but I'm going to put it in completing the square form by switching over the 5 over and setting that equal to 0 in a little bit. But let's do this. So 6 all over 2 and then square that. So that, of course, is 3 and then squared that. That's going to be 9. So this is the number that I will add and subtract to both sides. So let's put it in completing the square template form. Ready? I'm going to subtract that 5 over -5, because that's what we did last week. We moved the constant over to the other side, right? I'm just going to set that equal to 0, move it over to the other side, so that's -5, okay? This is going to be y squared and then plus 6x, all right? Now what you can clearly see is that this is going to be plus blank and then parentheses. And this right here, this blank was that 9. So I'm going to put the 9 here. But what I do to one side, I must do to the other. So we would have a plus 9 here. Now, maybe you're thinking, well, do we really need to set it equal to 0 because we're not really solving for x's here? And actually, you're right. We don't necessarily need to set it equal to 0. We could technically just replace this f of x with a y and just kind of transfer it over. We don't necessarily need to say equals 0 there. We can just move it over to the y side and then move it back. It doesn't matter. It's just sometimes when I say equals 0, students have a better understanding for it. So let's just keep it with that because maybe it's a little bit I just want to show you a different way to do it, and I think that's helpful. So I added the 9 to both sides, 9, 9, and 9. After I subtracted that constant term over, because I need to have it on the other side so I can kind of balance the equation a bit. Now when I have this, I can factor this to be x plus 3 squared. Looks familiar, right? Looks like a vertex form. And then this right here is just 4, y plus 4. I can subtract the 4 over, and this would, of course, be x plus 3 squared minus 4. This would be my vertex form, which then I can find my vertex. So this is -3, -4. That's my vertex. Hallelujah. Okay? So now, as you can see, what we did was we took the standard form equation and moved it into, or translated, manipulated it into vertex form. So we can pull out our vertex. Okay? Now, I could also just use this standard form. So I'm going to actually use this standard form and just say, okay, well, did I really need to find the vertex to graph this function? Well, technically not. Like, this is factorable. So if I set that equal to 0, guys, in my standard form, if I set it equal to 0, then that means this is x plus 5 and then x plus 1. So really, x equals -5 and -1. These are my x-intercepts. Okay? And I can also go more and just say, what's my axis of symmetry? My axis here is just x equals -3. And I can start finding all these things. I found the vertex, I found the vertex form, I found the x-intercepts, I found the axis of symmetry. I mean, I can find domain, range, and everything. So now what I'm trying to show you is that even if you're given standard form, you can find all of the necessary components that make up a quadratic. It's x-intercepts, it's vertex, it's axis of symmetry, it's domain and range. Like, we could go further and find the domain and range. I'm not going to, but I could. Okay? And so this is the cool part of this lesson. It's kind of bringing everything together that we've learned about quadratics from last week and now yesterday, bringing everything together so that we can see how it's all related, how the equation does relate to the graph, how the x-intercepts do relate to the graph. So I'm going to erase this because honestly, primarily, all you needed was this top portion for this slide. This was just kind of extra. This bottom was extra. This top portion was really good, though. This is all we needed for the slide. So let's erase this, and let's go through another example where I need to complete the square, to graph it. So how can I complete the square? Well, I'm going to, first of all, like they said, factor out the LC. If A is not equal to 1, well, A is 1. This coefficient, A is your leading coefficient. Well, that's 1, so I don't need to do that. So again, don't need to do it. I am going to subtract that over first, so I have y minus 4 equals x squared plus 6x. And now I do want a plus blank here, and eventually I guess I'll have a plus blank here on the left side. How do I get that plus blank? Same exact thing. I'm going to take 6 divided by 2. I'm going to square that. That gives me 9. I put 9 here. I put 9 here. This is y plus 5 equals, this is x plus 3 squared. Remember, if you're having difficulty figuring out what goes in this parentheses, just remember whatever is simplified in here, in those sets of parentheses where I'm boxing in blue, that's going to be that number. So that's a positive 3. So that positive 3 gets transferred there, and then I square it. So if that helps you remember what number goes there, then that's perfect. Okay, now I'm just going to subtract the 5 over. So this is now my vertex form. Okay, this is my vertex form, which is beautiful, right? Beautiful. So since that's my vertex form, I want to find my vertex. So this is -3 and then -5. I'm going to go over here, -3, -5. And of course, I'm going to see whether or not it opens up. It does open up. So it's going to look something like this. Very briefly. Again, I'm just briefly graphing them. I'm not trying to be all intense with the sketching here. I'm just briefly graphing them, and that's all I need. Okay? I did that. I subtracted that term. That was 9, and I graphed a vertex form. Now, the question then arises, and we're going to do this in the next slide. What happens? What happens if I want to know what this x is, what that x is? What are those numbers? And did I really get those right numbers before? Like, how do I know if those are the right places where the graph actually crosses the x-axis? Well, in order to find that, I need to factor it. In order to factor it, I need to know the quadratic formula, if it's not factorable, and I also need to know my factoring skills, my factoring trinomials, my GCF. So that's all stuff that we learned last week. So what if I don't want to put it in vertex form is what I'm really saying. Can I still solve for it? Well, yes, of course. So now we're going to get into what if I don't want to put it in vertex form? What if I want to keep it in standard form? And because of that standard form, what if I want to graph the equation anyways? Let's go through it. So this is the standard form for your quadratic equation. It's the exact same form that you see on your quadratic formula Desmos graph right here. This is just standard form, exact same thing. So don't worry. You've already seen it before. But here are the steps. I encourage you to write these down. Again, if the A is plus or the A is minus, it's going to be up or down, respectively. 2, vertex. I want to find the vertex. It is your x or y, or otherwise it's basically your HK. But the problem is I'm not going to use HK anymore because I'm not in vertex form. I can put it in vertex form surely by completing the square, like what we already did in the last 2 examples. But in this case, it's going to be x and y, and I'm going to show you why that is. Give a little blank here, a little space, because I'm going to give you a slight formula to find out, well, do I really need to put it in vertex form to find the vertex? The answer is no, you don't need to put it in vertex form to find the vertex. You can do this slight formula instead. So just give some room here. I'm going to show you that in a little bit. The axis of symmetry, of course, is just x equals your x value. I'm going to show you what that is. Find x-intercepts by solving f of x equals 0. So that's basically set your equation equal to 0. Or factoring. So set it equal to 0 by solving it and then just factor. Okay. You can also use the quadratic formula or anything like that. Find the y-intercepts by evaluating f of 0. Okay, and we're going to find the y-intercepts there. Plot the vertex, the intercepts, the x and y-intercepts, the mirror points, because it's reciprocal, it's symmetrical. So many math terms. Symmetrical with a parabola. And then I want to find the domain and range. So we're going to be given a lot of things here, and we're going to be asked to be giving them a lot of things. But that's okay, because these are all things that we should know how to do already. We're just kind of compiling it all together. So now for 2, this is the slight formula that I will be utilizing to find your x-coordinate of your vertex. So this formula is really nice. It's kind of looks similar to the quadratic formula, yeah? Because it does come from the quadratic formula. If I use this formula, I find the x-intercept. I find the the x coordinates, sorry, the x coordinate of my vertex. So using this formula, I find the x coordinate of my vertex, okay? And then I can plug it back in to find y, and I'm going to show you that in a little bit. So step one, is it going up or down? Well, I just look at my equation, and I notice that this is a plus, so that means it goes up, okay? Step two, I want to find my vertex. So my vertex, using this formula, okay, I want to find my x, and then I want to find my y. So actually, let me put a blank here. I want to find my x, and then I want to find my y coordinate. That will give me my vertex for my equation, for my graph here. So how do I find it? Well, first of all, I need to find my x. So x equals negative b all over 2a. B here is negative 2, and then my a here is just 1. So I'm going to do a minus a negative 2, because there's a built-in negative inside my formula, but b is also negative, all over 2 times 1, which is my a value. This becomes 2 all over 2, which becomes 1. So my x value here is 1, and I'm going to put that 1 right there. Okay, I'm going to put that 1 right there. Now, how do I find my y? Well, if I already know what x equals for the x coordinate for my vertex, all I have to do is just plug that value in to my original function to find what y equals, because that's what it says. Y equals blah, 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 blah. So let's do that. Let's plug in 1 squared into my original equation, minus 2, so that I can find my y coordinate of my vertex, and then minus 3. So what this equals is 1 minus 2 minus 3. Order of operations tells me that this is going to be negative 1 minus 3, which equals negative 4. So negative 4 is my actual y coordinate for my vertex, negative 4. So I'm going to put it up here, negative 4. That means I can actually graph it. So 1 and then negative 4 goes right here. Perfect. Now, axis of symmetry, that's just going to be x equals 1. It's always going to be my x coordinate of my vertex. So that means it looks something like this. Okay. Find the, for step 4. Step 4, find the x-intercept. So that means I need to actually factor it, if it's factorable. So let's see, is this factorable? It is. So I'm going to say 0 equals, this is x squared minus 2x minus 3. How is this factorable? Well, again, guys, you have to think about it. What are factors of negative 3 that somehow, some way add up to negative 2? Well, that is just simply x minus 3 and then x plus 1. So minus 3, negative 3 times 1 is negative 3. Negative 3 plus 1 gives me negative 2. So that means x equals 3 and then negative 1. These are my x-intercepts. So I'm going to actually plot those on my graph. Now watch, when I actually do this, it's going to be great, because when I plot these, I can actually see where the graph is starting to form. I don't need to kind of guess anymore. Okay, so I can start plotting this. This is going to be 3 right here. So that means it's going to cross the x-axis right there. And negative 1, so it's also going to cross the x-axis right there. Now also notice this, guys. You ready? They are equidistant from my axis of symmetry. That means it is symmetrical on both sides. That's pretty cool. Okay, so you know you're doing it correctly when it's symmetrical on both sides. Let's start on 6 then, or sorry, 5. Let's do 5. My y-intercepts. What are my y-intercepts? So I just found my x-intercepts. What's my y-intercepts? Well, I need to evaluate f of 0, which means f of 0 is where you're plugging 0 in for x. So I'm plugging in 0 and then squared, minus 2 times 0 and then minus 3. Well, that just simply is negative 3. So that means f of 0 here, f of 0 is the same thing as saying this point. My x was 0, and then I got out negative 3. That is my y-intercept, and that's what I'm going to plug in. Okay, So 0, -3. So right here. So notice how we don't necessarily have too much of a graph. However, with all of this information, the vertex, with the x-intercepts and the y-intercept, we can then plot them and then plot the mirror points. And that's exactly what I will do. I will plot the mirror points. The other mirror point I'm missing is right here on the other side of that axis of symmetry. And because of this, I can now graph it. Perfect. So it should look something like that. That's pretty cool. Let's go to domain. My domain is just -infinity, of course, positive infinity, always, always, always. My range, it doesn't start existing until when I go bottoms up. It doesn't start existing until -4 here. So that means bracket, -4, and then goes up forever. So positive infinity. It does have a min at, so it does have a min at x equals 1. Okay, x equals 1. Sweet. So this is what the graph looks like. I think that's pretty cool. Let's erase and let's go through another example. So what we call maybe putting it in intercept form, and then after that we'll have one more example with systems, quadratic systems, and then we'll be done. So intercept form. This is basically the same thing as standard form. I mean, standard form and intercept form basically can be used interchangeably. So when I say standard form, I really do mean intercept form. It's the exact same thing. Is it going to open up or down? It is going to open up because that's a positive. My second step is to find my vertex. So vertex, it's going to be blank, comma, blank. I want to find what that is. I can by using this formula right here. So x equals negative, and then my b value, -13, all over 2, and then my a value is 1. So that's going to be 13 all over, because that's going to be positive. So this is going to be 13 all over 2, which reduces down to about 6.5. So really nasty x value there, but that's okay. So that's 6.5. All right. And then if I actually plug it in, and I'll let you guys do that yourself, but when I plug 6.5 into my original equation, I get this. I get -6.25. Okay, so this is my y value, and I'm going to put that right there, 6.25. So that is my vertex. So 6.5 is roughly right here, and then -6.25. So it's probably going to be right there, roughly, right? Awesome. I know my axis of symmetry is also this. So let's draw that real quick. And then let's say that that's x equals 6.5, not 25, 6.5, because that's what it is. Okay, make sure you get the x equals. It's important. You need the x equals. For step 4, find the intercept. So let's see if this is factorable. Is it factorable? I think it is, because think about it. What's factors of 36 that somehow, some way add up to 13? That's 9 and 4. So that means x is -9 and x minus 4 there. So multiplied together give me positive 36, but when added together give me negative 13. So that means I have x, let's actually skip that. So let's just do x equals 9 and then 4. So these are my x-intercepts. So I'm going to start plotting them. This is 9, and then this is 4. Notice how it's also equidistant from the axis of symmetry. Okay, find the, it doesn't say find the y-intercepts, but we could find the y-intercepts, and I will. So the y-intercept is just 36. It's going to be way, way, way up there. And so if I just plug in f of 0, so if I plug in 0 for this, that goes poofy, that goes poofy, I just get 36. Now, obviously, I can't plot that. It's going to be way, way up there. But that's where it crosses the the y-axis. So after I got my vertex, I got those points, I can basically give a rough sketch, not a beautiful sketch, just a rough one, and that's going to be fine with me. So it's just a rough sketch of what it would technically look like. What's my domain? My domain is negative infinity to positive infinity. What's my range? Since there is a min here, that means when I go bottoms up, I look at that value, and that value is just the same as the y-coordinate of my vertex, which is going to be negative 6.25, and then all the way to positive infinity. Okay? It does have a min at x equals 6.5. Fantastic. Okay, now that I showed you all of that, I'm going to use this example, okay, and I'm going to actually use it on Desmos. So I'm going to look at this example, I'm going to use it on Desmos so that you guys can use Desmos as much as you want, and it will graph it for you. It'll give you your x-intercepts, it'll give you your domain, or sorry, your vertex and everything. Okay, so I'm going to show you that to you. So x squared minus 13x plus 36. Let's go to Desmos for this one question and show you how to do it. So this is what it is. Let's actually make this projector mode so you guys can clearly see it. That'll probably be better, right? Okay, so this is my formulas. It's undefined right now, but because that means it's imaginary, but let's change this. My A is 1. My B, we said, was negative 13. Okay, funky stuff that happened there. And now what I want this to be is 36. Okay, so that'll be 36. So now I do get my x-intercepts to be 9 and 4, and that's what I got, right? So 9 and 4, I can click on these, 9 and 4, that's fantastic, right? But the part that I did not show you last week using this formula is the bottom part where now you can use it, and now it gives you your vertex form, essentially. It gives you your vertex, not vertex form, but it gives you your vertex. You could use this information to then plug it into vertex form if you wanted. You can say y equals, and then this would be x minus 6.5 squared, and then minus 6.25. If I graph that just straight up as it is on Desmos, which I will right now, you will get the following. So y equals, and then x minus 6.5 quantity squared, and then this is minus 6.25. So notice how I get the exact same equation. So you could put it in vertex form after you get your vertex, or you don't have to. So really, Desmos uses all of what we just taught, all of what I just taught you, but you can just play around with it and you can still get the vertex form. As long as you have your vertex, you can get your vertex form. You don't even need to complete the square really at all. Notice what I just said. You don't need to complete the square really at all. If you don't want to, plug it in here, find your h for your vertex, find your k for your vertex, and that's it. So remember, this is your vertex, hk, which means it is 6.5, comma 6.25, and that's a negative. But that's exactly what I have here. So again, Desmos is very, very helpful. That's your vertex form. It's the exact same equation as the standard form. Okay, very, very cool. Very, very cool stuff. And also, lastly, they tell you your axis of symmetry, which is x equals negative, or sorry, x equals 6.5. Okay, x equals 6.5. That is extremely, extremely something you need to know. It's x equals, not just 6.5. That doesn't make any sense. It's x equals 6.5. And I could graph that if I wanted to. So if I wanted to, I could graph that. And that's exactly what we had before. If I wanted to, I can make these into fractions, right? I can make those into fractions if I wanted to. Maybe Desmos or Math Excel wants fractions. Hey, plug it into Desmos real quick, get those fractions, toggle those buttons, and then you can get those fractions here. Okay? Pretty cool, right? And then, of course, lastly, I can just click on this and I can just look at my my vertex as it is. And that's exactly what we got, right? Sweet. So use Desmos as much as possible, as much as you want to use it for this. Again, this is found on Google Classroom. This link, this Desmos link, is found on Google Classroom, Unit 3, and it's the very first thing, quadratic formula, Desmos link. So please feel free to click on that and use it during your test quiz, homework quiz, whatever. Let's go back, let's erase this, and let's go to town on our last example. So this is systems review, just linear and quadratic equations. Basically, I graph both functions and I just look for intersection points. I mean, this is something that we've already done. So let's graph it. Let's try to go to town. This is an equation, this linear equation. So that's really easy, right? I'm just going to solve that right away. I'm literally just going to do that right now. So my b value here is -5 and my m is 2. For my linear equation. So -5 is down here. And then I go up 2 over 1. So up 2 over 1. Up 2 over 1. Up 2 over 1. I'm just going to continue this because I don't know where it's going to intersect. So because I don't know where it's going to intersect, I want to make sure down 2 over 1. I want to make sure I get a really, really solid line here. And I'm actually going to use this to get a nice line. Let's move my face. Okay. Sweet. So that's basically my line. Pretty cool. Awesome. Okay. Let's look at my other one right here. Can I factor this? Since I already graphed that, let's do this one in blue. Can I factor this? Well, I can. Okay, I can factor this. So this is going to be 0 equals, and this is x, and then -5, and then x plus 1. So that means x equals 5, and then -1. So yes, this tells me my intercepts. It doesn't tell me my vertex, and I do need my vertex to graph this equation, this quadratic equation. But first, let's find where those are at. So this is -1 right here. I know it's going to cross right there. And at 5, so it's going to cross right there. Perfect. Awesome. Okay, now let's find my x coordinate for my vertex. So it's -b all over 2a. -b all over 2a. So this equals -b, so that's going to be -4, so that's going to be a +4. Is a negative times a negative gives me a positive, and then 2 all over times 1 is just 2, so this equals 2. So my vertex here so far is just 2 comma something. What is that something? I need to know. So I take this 2 and I just plug it back in here. So that means y equals 2 squared for for x squared. 2 squared is 4. And then minus -4 times 2 is -8, and then -5. Order of operations tells me this is -4, and then -5, which is -9. So this is my y coordinate of my vertex, -9. Let's go to town and plot that. I'm just bouncing all over here. So 2, and then -9 all the way right here. Now, a cool thing that you could do here is once you find your x-intercepts, all you need to do, since it's, you know the vertex is going to be equidistant from those x-intercepts. That's a symmetrical property. All I have to do is just count. Okay, that's 1, 2, 3, 4, 5, 6. That means it's going to be 1, 2, 3 right here. I know my axis of symmetry is going to be right there. Okay, awesome. So then I basically just start plugging it in and trying to find where this is going to cross. Like, where will this actually cross? Okay. And let's find out. Let's find my y-intercept last, my y-intercept for my quadratic equation, and let's find out these points. So for my y-intercept for my quadratic equation, I'm just going to say f of 0, which means I'm going to plug in 0 here, that goes poofy, plug in 0 there, that goes poofy. So this becomes -5, which is 0, -5. Now I go to 0, -5, and what do you know? You start to see this. Notice how that's already a point there. So this is one intersection. That's one intersection point that I know will hit. So I'm going to kind of do that. And then once we have this kind of graphed, we start to see that this will be another intersection point. But it's probably not going to be there, so let me actually erase. Could you use Desmos to double check that? Actually, yes, you could use Desmos to double check it. I believe it's going to be right here. That's where it's going to be intersecting at. But let's use Desmos right after this and double check it. That point is going to be 6 and then 7. So this is one solution. Okay. And then my other solution is down here. That's 0, -5. So this is another solution. So I hope this kind of jogs a little bit of your memory of what we did when we did nonlinear systems a couple weeks ago, almost like a month and a half ago. Okay, let's graph both of these on Desmos and see if those points are correct, because we always want to use Desmos just in case to double check. But this is how you'd basically do it, just graphing by hand. Okay, graphing by hand. Let's do it. Let's find out. Awesome. Now you could also substitute this. We didn't do that. We didn't substitute this at all. You could substitute it, solve it algebraically, and factor that, simplify it over. We didn't do any of that. We're just solving it using graphing. Okay, so what I'm going to do first is graph my quadratic. So I'm actually going to change these values, and I'm going to change it to be -4, and then this is going to be -5. Okay. So that's my quadratic. These are my x-intercepts. I already told you guys that. We already found that to be the case, right? We already found that to be the case. So just like this, -1, 5. Yep. And then my vertex is 2, -9. So that's my quadratic that I'm interested in. All right. That's my vertex. That's my axis of symmetry if I wanted to put that there. So now that that's done, let's kind of go to another one and just type in my linear equation. So 2x minus 5. So this is my linear equation here. Let's actually make that one so that it matches. How about that? Because I think what we did was the quadratic was blue, right? There we go. So there. So it matches. All right. So we know we got that solution. That's where it crosses the intersection. So we know that's a solution. And then this one, let's see if we got it right. 6, 7. 6, 7. Okay, great. So I knew it couldn't probably be that one. That one, this one right here is too close to it. So I knew it had to probably be that one there. Awesome. So that is how I check it using Desmos. And this is my two answers, 0, -5, and 6, 7. So I hope that kind of jogs your memory from nonlinear systems, plugging them in, and then you see where they cross. Awesome. Let's erase this. And then let's go on to our summary. So what did we learn? Well, we learned how to recognize advanced characteristics of parabolas, specifically when it's on the intercept form and standard form, and how it relates to the vertex using -b all over 2a. Graph parabolas using standard form and intercept form, we also did that. Okay, we did also kind of review some linear systems and quadratic systems when we mix them together, but I didn't want to put that there because that's technically review. Make sure you go over your notes tonight during your homework. There will be a homework quiz tomorrow, and make good choices. Until next time, guys, this is Mr. Carlson. Be sure to like and subscribe.